Hey guys, hi, hello, namaste, adab, sat sri akal, assalamu alaikum, vanakkam, and khamma ghani to all of you. Welcome to today's class, guys, and this is your Prodigy series for ICSE 10th, and this is the one shot video for the topic circles. All right, circles. Okay, so in this topic, guys, we will be discussing the whole topic circles and the different types of questions which are present in this topic. So guys, my name is Gopal Paliwal. I am your master teacher of mathematics here at Vedantu. I have done my graduation from IIT Dhanbad and I have been teaching from the past 5 years. This is all about myself. You can see the credentials on your screen. Let's start today's class. So guys, in this topic circle, we can divide this topic in three parts. One is your angle properties. All right, then your cyclic properties, and then the tangent and secant properties. All right. Now, guys, in this session, since it is a one-shot video, I will not be discussing the proof of all the theorems. All right, I'll just tell you the theorems, and we'll be focusing on the numerical problems. We'll be focusing more on the questions. Okay, guys. So introduction first. What is circle? Circle is defined as the figure obtained by joining all the points in a plane which are at a constant distance from a fixed point. This constant distance is called radius, and this fixed point is called center of the circle. So in this center, let's say this is the center of the circle, all the points on the circle are at equal distance from the center. All right. Okay, then there are different parts: radius, distance between the center and any point on the circle; circumference is the perimeter of the circle; then chord is any line any line joining two points of the circle. Now those chord which passes through the center will be called diameter, and diameter is the largest chord of the circle and it is double of radius. Okay. Now, these are the theorems which you have studied in the previous grade. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So first one, if you'll see, suppose if we have a chord over here, and let's say this is the center of the circle. If I join the midpoint of this chord with the center, so remember, this line which is joining the center with the midpoint of the chord is perpendicular to the chord. Alright, its converse is also true. If you draw a perpendicular from center to any chord, that perpendicular will bisect the chord. Then perpendicular from the center of a circle to a chord bisect the chord, converse of it. Alright, greater is the size of the chord, smaller its distance from the center. You can compare this in this way. Suppose this is the center circle. Now this chord which is closer to the circle, and this chord another chord which is farther from the center. So the chord more closer it is from the center, the more will be its length, and more farther less will be its length. All right, then we have arcs. So we have minor arc, major arc. Main thing is, to define minor arc, major arc, we need one thing which is the central angle, the angle which is obtained at the center. All right, so we have one thing which is called segment. So segment is the region between a chord and the corresponding arc. Corresponding arc means, suppose if I take the region between the chord and the minor arc, then it is going to be minor segment. And if I take the region between the chord and the major arc, this is going to be major segment. All right. Similarly, over here, guys, you can see, suppose if I talk about the sector, sector is like slice of a pizza. Okay, so sector is the region between the two radiuses and the corresponding arc. So if I talk about the minor arc, it will be minor sector, and if I talk about the major arc, it will be major sector. All right, simple. So difference between sector and segment. Now let's come to our first theorem, which is very important: angle properties. What this property says, guys, that the angle that an arc of a circle subtends at the center, any angle which the arc subtends, the angle arc subtends at the center, this angle will be which it subtends at the center any point of the remaining part of the circle. So this angle at the center is double of the angle which the same arc will subtend in the remaining part of the circle. All right, for example, let's say in the first figure, if our arc is a minor arc, if the arc which we are seeing, angle subtended by an arc at the center, suppose that arc is minor arc. So this B C. Alright, this is my minor arc. This is the minor arc. This angle subtends an angle at the center, which is your angle BOC. Right? This angle BOC, in the first one, I can say, sir, this angle BOC will be double of any angle in the remaining part of the circle. So, remaining part anywhere on the major arc, join any point of the major arc with B and C. Let's say this angle BAC. So, will be twice of angle BAC. Alright. So, if this angle is 30 at center, it will be 60. As simple as that. Now suppose the angle, central angle, the arc for which we see the central angle, if that is a major arc, as in the second case. As in the second case. So here the arc which we are taking the central angle at, that arc is a major arc. So the angle subtended over here in the second one, the angle subtended at the center will be nothing but reflex of angle BOC. Yes or no, this is greater than 180 degrees, so reflex of angle BOC will be 2 times of angle BAC. So remember this diagram carefully. Okay, focus that angle at the center is given for which arc, and then in the remaining part of the circle the angle will be half of the central angle. In the third case, guys, if we are talking about the diameter, so diameter is subtending an angle of 180 degrees at the center. So in the remaining part, the arc is, suppose, let's say this one. This is the arc. So in the remaining part, the angle will be half of 180, which means 90. And from here, we say angle at the semicircle. Angle at the semicircle is always 90 degree. Always right angle. Simple. Alright. So this is your angle property. Is very important property. Then the second one, see, angles in the same segment are equal. Its proof is very easy. See, this angle and angle, we suppose this arc, if we are talking about, let's say this arc, subtend some angle at the center. Some angle at the center, let's say somewhere over here. Alright. Now this is, suppose, let's say x, angle x degree at the center. So I can say angle A will be half of this central angle, and angle B also will be half of the central angle. In the remaining part, anywhere I can pick. So we'll get angle A is equal to angle B. Simple. So angles in the same segment are equal. This is very useful. The first two which I have told, they are very important in numericals. Very important in numericals. Alright. Okay. An angle at the semicircle is 90 degree. Okay. Now let's look at questions, guys. How this kind of question will look like. Okay. The first question given, angle CAB. CAB. Alright. I can see CAB, this is B over here, and this is D. CAB is 75 degree given over here. Angle CBA, CBA, only this is 50 degree. Find the value of angle DAB. Where is DAB? DAB is this angle. Alright, so don't say it is 75 by 2. It can be anything. So angle DAB plus angle ABD plus this complete angle. Okay. So guys, understand, if I want this complete angle, I can say, sir, in triangle ABD, focus carefully. I can say, sir, in triangle ABD, I need to find out the sum of angle DAB plus angle ABD. For that, I need to get the value of this angle, angle ADB. Because if I know angle ADB, 180 minus will be the sum of this. Alright, how do I get angle ADB? So beta, first what I will do, I will start, I can start with triangle ABC. Right? I can start with triangle ABC because in triangle ABC we know one angle is 75 degree, other angle is 50, so we can easily find out the third angle. So I can say, sir, in triangle ABC, angle ACB, which we don't know, plus angle 75 plus angle 50 is equal to 180 degree. So angle ACB, 75 plus 50 is 75 plus 50 is 125. Shift 125 over there, you'll get 55. Right? Alright. So angle ACB is equal to 55 degree. Now if angle ACB is equal to 55 degree, Guys, understand, if I talk about the chord AB and this minor arc AB, this is the minor segment, the remaining part is major segment, and angles in the same segment are equal. So I can say, sir, angle ACB will be equal to angle ADB. Both should be equal to 55 degrees. So this angle will be equal to 55 degrees. Now I can use the angle sum property in triangle ABD. Alright, so I will say, sir, in triangle ABD, first thing, angle DAB plus angle ABD plus angle ADB will be equal to 180 degree. So angle DAB we don't know, plus angle ABD which we need to find out, plus 55 is equal to 180 degree. So I'll get angle DAB plus angle ABD will be 180 minus 55, which is equal to 125 degrees. And that's what I needed. That is what I needed. In this question, I cannot find out the separate values of DAB and ABD, but I can tell the sum will be 125 degrees, because to find out the separate values, or it can be found as well if AD is a straight line. This is total 90. We can find out separate values as well, but not required right now. Right now, it is not required. Okay. All right. ठीक है बच्चा party. Let's go ahead. Now the next theorem which we have is cyclic properties. What is cyclic properties? The first part we have finished with the angle properties. Cyclic properties is about the cyclic quadrilateral. Now remember guys, cyclic quadrilateral is that quadrilateral in which the four vertices of the quadrilateral, all the four vertices of the quadrilateral are on the circle. Then only it is called cyclic quadrilateral. Okay, all four vertices must be on the circle. Now in this, remember guys, opposite angles are supplementary. This is a very important property of cyclic quadrilateral. It's a very important property of cyclic quadrilateral. Angle A plus angle C is equal to 180 degree. Angle B plus angle D is equal to 180 degree. It's a very important property. Okay, opposite angles are supplementary. From here we can get another property that, suppose they go exterior angle of cyclic quadrilateral is equal to the opposite interior angle. How? It's very easy guys. They go, we know angle D and this angle over here, let's say it is X and it is Y. Okay, these two will be supplementary, yes or no? Okay, so, or why to keep it Y, I can say if angle D is equal to X. Okay, chalo, let's say if I take angle B as X, so angle B plus angle D is equal to 180 degree. So angle B is X plus angle D is equal to 180. You'll get angle D as 180 minus X, right? So this angle we have got it as 180 minus X. Now I can also see, sir, this angle B which is X plus, let's say this is the point D, angle CBD plus angle CBD is equal to 180 degree, because they are a linear pair as well. So X, so angle CBD will be equal to 180 minus X. Can you see guys, both are equal to each other. This is also 180 minus X. That's why exterior angle is equal to the opposite interior angle. Okay, easy one. Now let's look at the question. In the given figure, find, they go, what do we need to find out? We need to find out angle BCD. So angle BCD we can easily find out. I can say, sir, angle A plus angle BCD, which is angle C, is equal to 180 degree, because they are the opposite angles of a cyclic quadrilateral. A, B, C, D, all four are present on the circle. So angle A is 105 plus angle BCD is equal to 180. You will get angle BCD as 75 degree. Simple. Next one, angle ADC. Angle ADC, you want to find out this angle. How do I find angle ADC? So guys, if you'll see over here, it is not mentioned clearly, but in the diagram it is shown that AB is parallel to CD. In the diagram it is given AB is parallel to CD. So if AB is parallel to CD, I can say angle A plus angle ADC also will be equal to 180 degree, because they are interior consecutive angles. So from here angle ADC is again 180 minus 105, which is 75 degrees. So this is 75, this is 75. Then angle ABC. If you want to go for angle ABC plus angle D, again you can say is equal to 180 degree because they are opposite angles. So angle ABC, which is we don't know, angle ABC, which we don't know, plus angle D is 75 is equal to 180 degree. So you'll get angle ABC as 180 minus 75, 105 degrees. Alright, so this is how all the angles will be known. If AB parallel to CD was not given, then we would not be able to find out all the angles. But this information was important for us. Okay, alright, simple. Next one. ABCD is a parallelogram. A circle passes through vertices A and B, meet side BC at P and side AD at point Q. Show that quadrilateral PCDQ is cyclic. Now see, without diagram of this question, you will not be able to understand anything about it. Without diagram, it will not, you'll not be able to understand anything about it. So let's draw the diagram, right? Let's see what the diagram says. Okay, let's say this is a quadrilateral A, B, C, D. Okay, now circle passes through vertices A and B and meet BC at point P and AD at point Q. So if it is passing through AB, I think I have to keep AB the smaller side. If I will keep AB as the smaller side, then my diagram will be clear. Yeah. A, B, C, D. All right, A, B, C, D. Now they are saying a circle passing through A and B. All right, so a circle, if it passes through A and B, so let's say it is something like this. This is the circle which is passing through A and B, meet side BC at point P. So this point will be point P and the side AD at point Q, side AD at point Q. All right, show that quadrilateral PCDQ, this quadrilateral PCDQ also is cyclic. What we need to show? That cyclic this quadrilateral PCQD, this is also cyclic. Okay, अब guys देखो what you'll do. देखो, if it was about the quadrilateral ABPQ, we know it is cyclic quadrilateral because it is lying on the circle. So I can say, sir, ABPQ is cyclic quadrilateral. ABPQ is cyclic quadrilateral. So if ABPQ is cyclic quadrilateral, what we can talk about the angles? देखो, now understand this thing, guys. Whenever we have to prove any quadrilateral to be a cyclic quadrilateral, whenever you have to prove any quadrilateral to be a cyclic quadrilateral, always focus on proving opposite angles supplementary. Always focus that what do anything by something or the other way, you have to prove the opposite angles are supplementary, and that's what I'm going to do. That's why I'm talking about the angles. That's why I'm talking about the angles. All right, ABPQ is a cyclic quadrilateral. So I can say, sir, this angle A is equal to this angle A and angle P, they will be supplementary. And I can say, sir, this angle and this angle are going to be equal. Yes or no? Exterior angle theorem. So I can say, sir, angle A is equal to angle QPC. Exterior angle theorem in a cyclic quadrilateral. Alright, angle A and angle QPC are equal to each other. Alright. Then what else do we know? What else do we know? So angle A and angle P, we have told that they are equal. Now I need to prove the supplementary thing, right? Then I can say, sir, angle A and angle C will also be equal. Angle A and angle C will be equal. Angle C also will be equal over here because opposite angles of a parallelogram. Angle A is equal to angle C. Both are opposite angles of a parallelogram. Let's do one thing. Let's write the names. Let's say they are x degrees. Here also give them x degrees, so that it will be easier for us to understand. This is x degrees, x degrees, x degrees. All right. Now guys, I know that angle C plus angle D, angle C plus angle D is a supplementary, angle C and angle D will be equal to 180 degree, because adjacent angles of a parallelogram are supplementary. Adjacent angles of a parallelogram. At the end, the ABCD was given parallelogram. So C and D were supplementary. C and D are supplementary. So I can say angle C is x degree plus angle D is equal to 180. You got angle D is equal to 180 minus x. Right? Angle D is what, beta? Angle D is 180 minus x. Now you can see in quadrilateral. In quadrilateral PCDQ, we can say angle P plus angle D, or angle P, instead of writing angle P, let's write the full name, angle QPC. Angle QPC plus angle QDC will be equal to, angle QPC is x plus angle QDC is 180 minus x is equal to 180 degree. And if opposite angles are supplementary, opposite angles, it means what? Opposite angles are supplementary, and if opposite angles are supplementary, I can say PCDQ is a cyclic quadrilateral. So it's all about proving the opposite angles to be cyclic quadrilateral, nothing else. Okay, this is all it is about. So guys, now after this question, you encounter any question, always remember that if you have to prove any quadrilateral to be a cyclic quadrilateral, focus on proving it to be a focus on proving that opposite angles are supplementary. That's the only proof we go for whenever we have to prove any quadrilateral a cyclic quadrilateral. Alright guys, now before I move ahead guys, let me tell you one very important thing, that you guys can register for the Vedantu's Pro subscription for ICSE grade 10th. The link for that is mentioned in the description box of this video as well as in the pinned comment, and the coupon code is GPE Pro, and this coupon code will get you 10% off as well. Alright, so along with it you are getting 10% off. There is a very good course guys which you can see right now. Suppose if you come to the description box of this video, here you will find out the courses. Alright, so for CBSE 10th term 1, so here you can see the courses for ICSE as well. You can also join JEE foundation courses if you are preparing for the foundation courses, and NTSE courses also there. Alright, so click on this ICSE 10th course, and here you'll be able to see the whole price: Pro Lite, Pro Classic, Pro Plus. Alright guys, so after applying GPE Pro, you get flat 10% off, and these are your price after applying GPE Pro. Now Pro Lite is the course in which you are getting all the basic features, that is live classes, unlimited live classes, test series, assignments, notes, and doubt solving during the class. Then comes Pro Classic, and Pro Classic is the course guys in which you get one extra feature, which is 24/7 doubt solving support. You get access to Vedantu's Doubts app, and in that you can ask your doubts 24/7 and you'll get the solution for it. So that acts as a very good support system. Pro Plus is one more level up, because in this you get personal mentor who will be in contact with you. Any problem you have, be it academic, non-academic, you can always refer to them, and they'll make sure that each and every problem of yours will be resolved. They will even take your doubt classes, any doubts you have, everything they'll take care of. Alright guys, so these are the prices. If you want, you can try this course for 1 month and then take the complete course, or you can directly buy complete course as well. Now when you buy complete course, if you think suppose that this price is too much to pay altogether, EMI option is also there. Okay, so that is also there. Any other query beta you have, just go to the bottom of this page and there you'll find all the frequently asked questions. Okay, if you want to see some of the features, like suppose let me show you, like you can watch the replay of the class whenever you want. So if you'll watch the replay, you'll be able to see how the classroom setup looks like. Okay, so this is the normal recording, and if you want to come into the classroom session, this is how your alternate replay looks like. All right, so this is how the alternate replay looks like. You will see me over here. Let me show you myself as well. Suppose here you'll be able to see me. All right, we'll be solving all the questions, everything we are doing. See over here, all the notes, everything. You can watch the whole session again on your own. All right, so this will be serving as a very important thing. All right, you'll be able to see leaderboard at the end of the class, everything you'll be getting. Okay beta, ठीक है? So this is how you, first thing, unlimited, like as many times you can do the revision. Also, if you want to get the notes, just click on the notes of the previous classes which you want to get the notes for, and you will be able to get the notes of that class. All right, and that too you will see in teacher's own handwriting. Okay, you can see my handwriting over here. All right, wherever I have written the notes, everything, see, this is how you will get the notes. How amazing it is. All right, so these are the features, some of the features. You can also get access to unlimited classes. You can explore micro courses. Everything is there. All right guys, chalo, let's move ahead now with our next thing, that is tangent and secant properties. What is a tangent, what is a secant? So tangent is a line which touches a circle. Easy thing, tangent touches a circle, one point of contact. Now there is one important theorem guys, that when we draw a tangent, wherever is the point of contact, that point of contact, if you join it with the center, that will become radius. So remember, the radius at the point of contact is perpendicular to tangent. Radius at the point of contact is perpendicular to tangent. First theorem, very important. Next thing, if two circles touch, the point of contact lies on the straight line joining their centers. So if suppose two circles are touching externally or internally, the point of contact will be lying on the line AB joining their centers. Okay? Next, if we draw, देखो, if we have a point on the circle, suppose let's say a point T is on the circle. So from a point on the circle, you can draw one tangent. If a point is inside the circle, you cannot draw any tangent. But if a point is outside the circle, let's say this point P, outside the circle, you will be able to draw two tangents from a point outside the circle. And remember guys, these two tangents are equal in length. Also, this proof you get by proving triangle APO, let's say triangle APO is congruent to triangle BPO. Alright, so not only these tangents are equal, remember these two angles are also equal. Tangents are equally inclined on the line OP, as well as the radiuses are also equally inclined on the line OP. So these things are very quick shortcut which will be able to understand. Okay? Next is when two chords intersect internally or externally. Dekho, first thing, internal intersection means what? When suppose, dekho beta, this is your circle. This is your circle. Now one chord is chord CD and one chord is your chord AB. Not the chord CD and AB. Let me say these are two chords and which are intersecting at one point over here. Okay, let's say it is PQ, chord PQ, and let's say this is chord R S, and they are intersecting at a point M. Let's say, so guys, see, if this PM is equal to A, what they are saying, this length PM is equal to A and this length MQ is equal to B, and here this length RM is equal to C and this length MD is equal to D. So remember guys, A into B is equal to C into D. That means when two chords intersect each other internally means what? Inside the circle. When they intersect inside the circle, in that case, the segments in which they divide each other, first chord PQ is divided in A and B segments. First segment of length A and line segment of A and B. Second chord is C and D. Their product will be same. A into B is equal to C into D. First theorem. External means outside the circle. So it means, like, suppose there is a chord like this, another chord like this. Now see, they are not intersecting. This is a what, sir? They are not intersecting. But if I extend them outside, definitely they will intersect at some point. Alright, so remember this length, I will say suppose PA and PB, and here PC and P the same is here. PC and D. So remember over here also PA into PB is equal to PC into PD. Remember P to A into P to B, P to C into P to D. Here also I would rather like in this form only because this is the more common form which all of us know. Alright, I will say PA into PB. Okay, so here let's say this is a chord A, this is chord B, this is chord C, this is chord D, and the point of intersection is point P. So here also guys, PA into PB is equal to PC into PD. Remember this thing, be it internal, be it external, wherever is the intersection point, from that point to the ends of the chord. So PA into PB is equal to PC into PD, internal. If it is external, PA into PB into PC is equal to PC into PD. Very important, direct questions are asked from this theorem. Okay, then there is one more thing, that suppose from an external point you draw a secant. What is a secant, guys? Secant, remember, tangent passes through the, like tangent touches the circle. Tangent touches the circle. Secant passes through the circle. Like this. This is a secant. So secant passes through the circle and intersect at two different points. So let's say ED is a secant and EA is a tangent. So remember, tangent square EA square, or I would rather keep it as whatever generally written in the books, will keep that same naming so that it will be easier for all of you. Let's say it is P A and B and here PT. So remember, PT square is equal to PA into PB. Tangent square is equal to the product of the external segment and the whole secant, PA into PB. Alright, diagram, focus on the diagram. This much language, no need to remember, just read it once. That if a chord and a tangent intersect externally, the product of the length of the segments of the chord is equal to square of the length of the tangent from the point of contact to the point of intersection. But main thing is diagram. Okay, then if a line touches a circle from a point of the, this is your alternate segment theorem. Understand alternate segment theorem, what it says. Suppose this is your circle. At this circle, I have drawn a tangent. I have drawn a tangent, and from the same point only, I have drawn another chord. Alright? Okay. Now, beta, this chord has divided this circle into different segments. One is small segment, one is major segment, minor segment. Hai na? Alright, so this one, this smaller one, this is your one segment, the other is your other segment. Now, the angle between the chord and the tangent, understand, the angle between the chord and the tangent, this angle, the angle between the chord and the tangent, this angle will be equal to the angle in the alternate segment. Any point on the circle in the alternate segment, any point on the circle in the alternate segment, these two angles are going to be equal. Similarly, if I talk about this angle, tangent and the chord over in this direction, so this tangent will be equal to, now if it is the angle between the tangent and the major segment, so in the remaining part anywhere you pick, remaining segment, this and this will be equal. All right, so this is what is called, and the name of this theorem is what? Alternate segment theorem. Name of this theorem is what, beta? Alternate segment theorem. Important. All right. Okay, so these are the theorems, guys, which are there in your topic. Let's solve some questions. The first question, what it says: in the given figure, 5 times of PA is equal to 3 times of AB is equal to 30, and PC is 4. Find CD. So what I'll see, beta, they go. These three are given equal. I can say, sir, 5 times of PA is equal to 30. Shift 5 in division. PA is equal to 6. PA is equal to 6. Then 3 times of AB is equal to also 30. So AB is equal to 10. AB is equal to 10. So total PB will be 10 plus 6, which is equal to 16, right? And then they have given PC is equal to 4. So now guys, I know that PA into PB is equal to PC into PD, right? PA is 6, PB, many students they take 10, but the common mistake, don't take 10, it is PB, length of the complete secant, 10 plus 6, 16 it is equal to PC's 4 into PD. So from here you'll get PD as 6 into 16 divided by 4, 4 ones are 4 fours are, 4 6 are 24. So PD, remember, this complete PD is 24. What do you want? You want CD. So CD will be PD minus PC, which is 24 minus 4, which means 20 centimeter. So this is going to be equal to 20. Alright? Easy question. Okay, bacha. Next one. If the sides of a quadrilateral ABCD touch a circle, prove that. This you can remember as a theorem also, guys. If we have a quadrilateral which is circumscribing a circle, remember, some of the opposite sides will be equal. Now, how do I get it? See here carefully. First thing I know that length of tangents from an external point will be equal, beta. So I can say, sir, this length, let me choose a good color which will be visible. Okay. Okay. So let's say, guys, first thing, AS and AP both are equal, tangent from an external point. Similarly, BP and BQ are also equal. CQ and CR are also equal. DR and DS is also equal. Alright. So guys, I can say, sir, first thing, sir, AP is equal to AS. BP is equal to BQ. CR is equal to CQ. And DR is equal to DS. Now, the reason being, length of tangent from an external point are equal. Now, if I add all of them, you can see AP plus BP is equal to AB. CR plus DR is equal to CD is equal to AS plus DS is equal to AD, and BQ plus CQ is equal to BC. Hence proof. Alright. So this proof is easy. Directly numericals comes on this. So if you will remember it, numerical will be easy for you to solve. Okay, beta. Alright. Okay. So these are all the questions which we have. Try to solve this question in your homework, guys. Try to solve this question in your homework. In the given figure, a circle is inscribed in a circle. In a triangle, ABC touches the side AB, BC and AC at point D, E and F respectively. If AB is 12, BC is 8 and AC is 10, find the length of AD, BE, CF. Very good question it is. Think and answer. Alright, beta. Okay, so this is your homework question and this is all from my side in today's class, guys. You can register for Vedantu's ICSE courses. The link for joining is mentioned in the description box of this video, as well as in the pinned comment, and the coupon code is GPE Pro. Alright, to get 10% off. Alright, so guys, this is all from my side in today's class. Thank you so much for joining the session. I hope all of you enjoyed it, and I'll see you soon in the next class. Please, till then, please don't forget to like this video, guys. Share it with your friends. Subscribe to this channel if you're new here. Thank you so much. I'll see you soon. Bye bye. Sayonara. Khuda Hafiz to all of you. Bye bye, guys.